Hey folks, it's me, Demotro, with some huge mathematical news. Last week, I made a live stream about how a big online ongoing project called the Great Internet Mersenne Prime Search had announced that there was a new probable prime, but it wasn't in big headlines yet because they were still running more primality tests on it to confirm that this number truly was a prime number. And now the time has come that I was hoping for, where it's been officially announced and a press release has officially come out that this number not only has been verified to be prime, but that it is the largest prime number ever discovered by humanity yet. And this prime number, written in base 10, is over 41 million digits. And so you may think, well, we're not going to be able to really see that number today, but we can see a form of it because it is a form of prime number known as a Mersenne prime that has a very specific form, which is this also written in our base 10 system so far. 2 to some very large power for the primes they're currently checking, -1. And in general, a prime number that lands 1 less than any power of 2 is known as a Mersenne prime number. And although mathematicians have easy proofs for the fact that there's an infinite amount of prime numbers in general, it is still unknown whether there are an infinite amount of Mersenne primes. However, this sort of prime number is easier to test whether it's prime or composite than the average random number of its size. This form gives it the ability to have easier primality tests that can be run on that number. And in this case, they first ran an easier test, a Fermat primality test, that did show the number was probably prime, but that sort of test can have some composite numbers sneak through. They know that it's just to check whether a number is probably prime. So out of the many possible Mersenne prime candidates, they can check enough to eventually narrow it down to one that they want to run further primality tests on. And in this case, the further primality tests have shown that this is definitely prime. Now, this form actually gives it a very interesting structure in another base. But first, let me just note about the history of discovering large primes. Mathematicians have always been interested in prime numbers, the sorts of numbers that cannot be broken down into smaller whole number factors apart from 1 and themselves, because prime numbers are sort of a multiplicative building block to construct any whole number. You could arguably say any whole number larger than 1 has a unique prime factorization, or you could include 1 if you allow it to be the one with the unique empty prime factorization, being the empty product of no primes multiplied together. In any case, prime numbers have always been of interest to mathematicians, and so it's always told mathematicians some interesting data about how they're spread apart on the number line, which still has many mysteries to it, to find a bigger prime number than ever before. Partially just to show the ability of human accomplishment, almost like just trying to set a random world record, and partially because we can get information from these large primes that can tell us more about how primes are clumped and structured on the number line. Although we know there's an infinite amount of primes in general, there's many open questions about them, like we don't know whether there's an infinite amount of primes that land just 2 apart from each other, or many other things about how primes cluster and gap on the number line. So, finding large primes was always interesting to mathematicians, but it's difficult because mathematicians are still working on each year trying to come up with new factoring algorithms, equations that can test the factors of a large number, or just primality tests that could show whether or not it had any factors between 1 and itself. And these tests over history have made new achievements, first just mathematical ones, and now both mathematical updated formulas, as well as the ability to get help from computers and computing devices nowadays, have made the world record of largest prime be broken a number of times. But because of the easiness of factoring a Mersenne prime compared to another number of that size, these numbers have helped break the last 6, or actually now 7, records. The 7 largest primes, including this new one, that are known to humanity, are all of that form. And in fact, this was the one that previously held the largest known prime record until about 6 years ago. This one, or since about 6 years ago. This one was discovered in December of 2018. So it held the title for almost 6 years until this new one was officially announced today. Now, about these numbers, I noted they have an interesting form in another base, and that's because powers of 2 relate to base 2, or binary. And try and think for a second about what would be the form of 1 less than a power of 2 in binary. Well, we could say a power of 2 is 1 followed by a ton of zeros, because it just has a 1 on a spot representing a power of 2 in that base, and no other digits. And what would be 1 less than something that was 1 and then a ton of zeros? Well, in binary, it would be the maximum thing with 1 less digit total, and that would be loaded full of 1s. It would be a string of 1s before adding 1 would sort of reset to the next place, and we have a 1 and a string of zeros. Now, a string of 1s in binary, which is the form of all of these Mersenne primes. Some amount of 1s in binary, and in fact, it is the amount that's in the exponent. Mersenne primes, being something that you can prove interesting mathematical traits about as well, also have the interesting trait that if a number is prime of this form, 2 to some power minus 1, then the exponent must also be a smaller prime number. So that's also a smaller prime. And this one's also a smaller prime up there in the exponent. However, checking all those exponents is quite difficult when you get to numbers of this size. Now, computers have helped massively with these new ones. Not only has this great internet Mersenne prime search been a project to distribute software for many people around the globe to test the software that has been confirmed by a trustworthy organization that's just there to try and make these mathematical discoveries, distributing these softwares that are verified to check whether a number is prime, or in some cases to just be the first pass to check whether numbers are probably prime. And now that is not only something run on computers, but the newest one apparently was found by what they're describing as more of a cloud computer composed of many different GPUs. So the person who this discovery is attributed to is mostly the fellow who set those up and ended up finding this, who's named Luke Durant, but also to people who helped set up that website and overall project of the great internet Mersenne prime search, and people who made upgrades to the software that came out with better batches of mathematical formulas or software based on them that the people who test these used. And I will link in the description of this video the official press release from them, which is more clear about the names of people they would like to thank for this sort of group communal discovery, which is pretty cool that we're at the point where to find big enough prime numbers, it's almost something that a single person couldn't have achieved on their own, something that we must unite with a common goal to find. Now, finally, I should note that this form in binary also means that not only are these numbers just strings of 1s in binary, because that's 1 less than a power of 2, but this also means 1 plus 2 to the first power plus 2 to the second power plus a sum of all the powers of 2, including 2 to the 0th power, which is a 1's place, up to some point. So adding all the powers of 2, including the 0th power of it up to some point, gives you the same result as 1 less than the next power of 2. So there's many ways we could describe these numbers, but I definitely think that it's more interesting than noting, oh, it's this many digits and I can't write it down. It's most interesting to note that in binary, or base 2, the basically simplest, actually efficient base, it is that many ones in a row with no zeros in between. Now, this type of prime number, Mersenne primes, also has really cool connections to another number theory concept called perfect numbers, and something that I doubt will be as publicized as the new prime, but maybe should be, is practically just as cool, is that it links with a new perfect number. They can plug this prime number into a formula, and basically knowing the exponent of it would be enough, and then know that a certain other number is a form called a perfect number, which is a seemingly unrelated number theory concept because those are numbers which are exactly equal to the sum of all of their factors apart from themselves. And they're built in a very different way than a string of ones in binary. Now, I will explore that connection more in a full episode on my main combo class channel, my other channel that I treat a little more like a TV show of sorts with longer, more official episodes. And that will be sort of a follow-up with some more details about this discovery, as well as diving into that underrated connection with how a new perfect number has also now been discovered. The 52nd ever Mersenne prime to be discovered or known as a total set, and the 52nd perfect number known. Stay tuned on my combo class channel for that coming in a couple episodes, but first, there will be a long, more documentary-like finale episode that will be the next episode out on there as soon as I'm done editing it, because that will be wrapping up what I call grade -2, a particular era of combo class here, before we move on to grade -3. And funny enough, 3 is a Mersenne prime, so perhaps this is nice timing. Okay, thank you all for joining me for this little bonus video about this awesome piece of news. I'll link in the video description the press release with some more details about the computing softwares that were used to discover this and the names of people who they would like to include as contributors to this discovery. And who knows when this will happen again, because the last time was almost 6 years ago, and we're at an interesting point where the primes are getting harder and harder to test based on how many digits they are, or the possible primes, but also computing abilities are going up. So we shall see which of those accelerates faster, the difficulty of the size or the abilities of our computing. Perhaps we'll discover fewer and fewer primes, or more and more, or maybe back and forth in some way. In any case, I'm pretty excited about this news. We now know that the number in binary that is composed of 136,279,841 ones in a row is prime. And thank you for joining me.